Inside a Japanese rail factory, the E6 Shinkansen takes shape through precise structural engineering.
The process begins with structural alignment and controlled assembly.
Utilizing high-strength, lightweight aluminum alloys is a critical prerequisite for achieving the high-performance standards of the E6 train series.
Completing the material preparation stage enables the friction stir welding process to begin forming the primary foundational structure. The fabrication of the rail vehicle shell begins with the integration of unfinished aluminum sidewalls. Continuous longitudinal welding establishes the rigid structural envelope required for high-speed rail operation.
The elongated aluminum rail vehicle shell is now structurally stabilized and dimensionally verified for further structural integration. The elongated front section for the E6 high-speed rail vehicle is fabricated separately to match standard gauge train geometry.
Laser-mapped surface checks confirm the rail front curvature before reinforcement and trimming proceed.
Secondary structural welding begins to permanently lock the formed aluminum nose panels into a unified aerodynamic shell. Multi-axis geometric validation confirms aerodynamic curvature and rear interface tolerance before final structural stabilization. The aerodynamic aluminum nose is now dimensionally stabilized with a verified rear mating flange prepared for integration with the main rail shell.
Bogey assembly begins with precision frame positioning inside the rail manufacturing facility.
Traction motors are torque calibrated to meet rail propulsion standards inside the assembly facility.
Hydraulic torque systems apply calibrated force to critical suspension joints within the Bogey module.
Final verification confirms the Bogey module meets propulsion and suspension specifications before leaving the assembly hall. Robotic sanding prepares the aluminum shell for coating. A precision abrasive unit moves across the body panels under neutral paint booth lighting. Electrostatic sprayers apply Akane Crimson to the upper body zone. The robotic arm distributes the metallic red coating evenly across the primed panels.
Ensure the alignment is precise on this section. Confirmed. The edge is smooth. Good. Let's continue.
Paint thickness is verified across multiple body sections to ensure micron-level compliance.
Industrial polishing tools refine the cured clear coat to achieve uniform factory reflectivity.
Final inspection verifies paint thickness and surface uniformity within rail manufacturing tolerances.
Primary electrical backbone installation begins inside the hollow aluminum train body shell, with exposed structural ribs and sealing cable trays visible.
We're clear to increase the feed rate. Copy that. Monitoring tension levels now.
Transformer modules are integrated directly into the internal chassis to convert overhead power for the traction and auxiliary systems.
Grounding connections are trimmed and secured to stabilize electrical continuity. Pressurized pneumatic lines are integrated to ensure consistent braking system response. Internal wiring and pneumatic systems are now fully secured within the structural vessel.
The marriage process begins as the 30-ton aluminum car body is precision aligned over the pre-assembled Bogey modules. Permanent structural joining is secured through high-tension bolster bolts. A technician uses a long-reach hydraulic torque wrench to tighten the primary pivot fasteners. With structural joining complete, the car body now rests fully supported on its bogies inside the assembly hall. Seat tracks are secured along the reinforced cabin floor. A Japanese engineer verifies alignment using a calibrated laser level across the passenger compartment. Cockpit control displays are installed and electronically synchronized. A Japanese engineer secures the monitor housing into the console frame.
Throttle and braking assemblies are mechanically linked to the underfloor interface system. A Japanese technician secures the control unit into the cockpit base structure.
Sliding cabin doors undergo repeated pneumatic cycling to confirm airtight rail-grade sealing performance. With interior systems secured and calibrated, the structural cabin assembly is now prepared for final exterior surface treatment in the next controlled phase. Static clearance testing verifies the 13-meter aerodynamic nose geometry within regulated rail tolerances.
Static load validation measures weight distribution across all wheel sets. E6 Shinkansen, testing and validation stage.
Initiating static pressure test.
Confirmed.
Brakes engaged. Pressure steady at target.
Technical certification follows full static validation of mechanical and electrical systems. At operational speed, structural precision defines aerodynamic stability. NextGen Machine Works, building the impossible. Subscribe to join the future.